Today, class, we're going to learn about graphing linear inequalities. So if we're going to start with something easy, like x is less than or equal to 3. Does anyone know how to do that? Anyone? Okay. So what you do is you get a piece of graph paper. What's wrong, sir? Oh, you were going to tell me? You get a line, you make a grid. What kind of grid am I going to see? It's going to look like a purple line. I don't want it to be dotted, but that's okay. The way you do that is you pretend like you're graphing x equals 3. Does anyone remember what x equals 3 looks like? Yes, AJ.
It's straight up and down line.
Very good. It's a straight up and down line at 3. And so what I do is I come out here 3. And if this says less than or equal to, okay, that means you make it a solid line, meaning any point that is on the line is included in your answer. Okay, so I'm going to make sure that I make this a solid line. And I'm going to graph the line. This is x equals 3. Now, where do you think that all the points that are less than 3 are? Do you think they're on this side of the line? Or do you think they're on this side of the line? Where x is less than 3. Where all the, if this is 3, 0 right here, right? Where are all the points that are less than 3? Left or right? Very good.
Left.
On the left side, right? So you really what you're supposed to do is pick a point on the left side, like this is the point 0, 0, and see if it makes this relationship true. You plug in 0 for x. Is 0 less than 3?
Yeah.
Yes. Okay, so since this point works, you shade in this direction. Okay, so you do something like this. So this is the graph. An inequality means you have to shade on one side of the line. All right, so this says all the points where the x value is less than 3, and you shade on that side. Okay? Is that hard? Is that weird? So, would x equal -5? Would that be a point? Would that be in this area?
Yes.
Yes. How about x equals 4?
No.
No, it'd be over here, right? So that's not part of the solution. All right, it gets slightly more complicated, but not a ton more complicated. So I'm going to start with a piece of graph paper, and I'm going to try to graph x is greater than 2x minus 1. So I'm going to draw my xy axis. You guys are a really nice, quiet, respectful class. Okay. What did I say? Y is greater than, that's not greater than, is it? Don't write that. Y is, oh, I want to erase that. Oh, I have an eraser on this thing. Look at that. All I have to do is push the button. Y is greater than, let's say, 2x minus 3. So the way you start off with each of these, you graph, first you graph the line y equals 2x minus 3. Can anyone tell me how to graph that? y equals 2x minus 3. What do I do with this minus 3?
You go down 3.
You go down 3. That's the y-intercept, right?
So going up 2.
So I'm going to put a point down here at 0, -3. That's your y-intercept. And then what Maddie said, this means a slope of up 2 and over 1, right? Or over 1 up 2. So from this point, I'm going to go over 1 up 2 or up 2 over 1, same difference, okay? Do that a couple times. 2, 1, 2, 1, 2, 1. Whoops, that's not good. That's 2, 1. And then I draw a line through those points. Now in this case, I'm going to make this line, and my line tool, right? I'm going to make it a dotted line. And I'll talk about that in a second. And the reason I'm making a dotted line is because this says greater than. It doesn't say greater than or equal to. So when I connect these points, my line looks like that, and you should make it a dotted line, not a solid line, okay? Because if it says greater than, it's not included in the solution, all right? And now I have to decide which side to shade on. Where do you think greater than 2x minus 3 is? Above or below the line?
Above.
If it says greater than, chances are it's going to be above. If it's in point slope form like this, slope intercept form, that's a good way to kind of think about it. So if it's bigger than, you shade up. You got to be careful when it's in standard form, which I'll talk about in a minute. Okay? So what you do, you could either just shade above or pick a point. What you should really do is pick a point, right? And the easiest point to pick, if it's not on the line, is 0, 0. All right? And what I do with that 0, 0 is I take it and I plug 0 in for x. I'm going to move this. I'm going to plug in 0 in for x. And I'm going to plug 0 in for y. And see if it makes this inequality true. So when I do that, I get 0 is bigger than 2 times 0 minus 3. And when I simplify that, I get 0 is bigger than, what's 2 times 0 minus 3 equal to? Negative 3. Is that a true statement?
Yeah.
Yes, that's a true statement. So when I pick this point, and I made this inequality true, and this point is on this side of the line, that means that when I shade on that side of the line. So I'm going to shade everything to above that line. Where's my nice green? There's green. Let's go blue. Blue is pretty. Okay. So I'm going to shade over here, this way. So any point that I pick in this area will make this inequality true. Okay? And that's what graphing an inequality looks like. Okay? Now, just to show you, if I did pick a point out here, like say I were to pick the point 1, 2, 3, 4, 0, okay? 4, 0, and I try to plug it in here, okay? So I'm going to plug in, instead of plugging 0 in there, let me erase that. Oh, I haven't erased. Just, you don't have to write this down, but instead of plugging in 0 in there, I'm going to plug in 4 in there. And 4 comma 0 would look like this. And I would get 0 is bigger than 2 times 4 minus 3. Is that true?
Yeah.
What's 2 times 4 minus 3?
No.
5, right? Is 0 bigger than 5? True or false? False. So since when I pick this point and it makes my inequality not true, that means that the solution must be on the other side of that line, right? Not on this side. Okay, one more and one word problem, and then we'll be done.
Wow.
Okay? You like word problems, right? Tony?
No.
You don't?
No.
Oh, I thought you did. All right, so one more. New paper. 3x minus 2y is less than or equal to 6. So we're going to graph 3x, ooh, I like this color, 3x minus 2y is less than or equal to, do I have negative 6 or positive 6? Positive 6. Right? So again, I'm going to make a xy axis on here. I'm going to not make it dotted, make it solid. Ooh, that looks pretty. Ooh, it's green. Is it green? Sure, why not? And then I'm going to go this way. So you don't have to have this in, you don't have to put it into slope intercept form because this is in a nice standard form. So the way to graph this, we want to graph 3x minus 2y equals 6. And if you remember how we did that, we made a little table, x, y. We plug in 0 for x. When x is 0, what would y have to be? If I cover up this, what's negative 2? It would have, do you guys see where Mary got negative 3? Okay. If I use the cover-up method, when x is 0, if I cover this up, then negative 2 times negative 3 gives you 6. When y is 0, what's x got to be? 2, right? I cover up this, 3 times 2 would give you 6. So those are my x and y intercepts, which makes this easy to graph. Go 0, negative 3, and 2, 0. Okay, should I make this a solid line or a dotted line? What do you think? What do you think, Luke? Solid line or dotted line? It says
Solid.
less than or equal to.
Solid.
Solid, very good. And the reason you make it solid because this says less than or equal to, okay? So I'm going to go over 2, up 3, over 2, up 3. I'm going to try to draw a line that goes solid line through those points. Okay? Now I have to figure out which side to shade. Now with these you got to be careful. You can't just assume that if it's less than you shade down here. Okay? Because it's not in slope-intercept form. That's true if it's in slope-intercept form, but this is not. So you really have to pick a point. And always, if that point, if 0, 0 is not on the line, choose 0, 0 because it's very easy to plug in. So when I take 0, 0 and I plug into here, I get 3 times 0 minus 2 times 0. And I want to see, is that less than or equal to 6? So I have a question mark there. What's 3 times 0 times negative 2 times 0? 0. Is 0 less than or equal to 6?
Yes.
Yes. So since this point made this inequality true, then I shade towards that point. Okay? So I'm going to take I'm just going to color in lines on this side. Okay, so you're going to shade like over this way, and that's what that one looks like. So if a point is on the line, would this point be a solution to that inequality? Yes, because it says less than or equal to. This is a case in which it's equal to 6, right? But this would be a place where it's less than or equal to 6. Any point out here would not be a solution to that inequality. Okay? So I'm going to give you some steps. Okay? And steps, this would be useful to steps for graphing inequalities. Inequalities. And the first step is going to be 1. Graph the line. Okay, so first you just graph the line like it's an equality. Use y equals, okay, whatever, or something like that. So you want to just graph the line by itself without worrying about the inequality. Okay. 2.
Write these down. These are good steps to follow
Okay.
when you're doing your homework.
Make the line solid or dotted. Okay. Depending if it's greater than or equal to or less than or equal to, that's a solid, right? And or greater than or less than or greater than, that's dotted. 3, you're going to pick a point. Pick a point. Oops. Pick a point. Point. I'm getting used to my new pencil. Point not on the line. And the best one, like 0, 0, if it's not on the line. If 0, 0 is on the line, then you don't pick that point. Okay? And plug into the inequality. Of a t. Okay? If point you picked makes it true, shade toward the point, toward the point.
Hey, just as a question,
What?
is it possible that both sides
If-
won't be true to the
No,
equation and the
impossible.
dots on the lines?
No.
Okay. Just
If
curious.
not true, shade away. Okay, I'm gonna pause. Here's a word problem
That's possible.
based on inequality. Suppose your budget allows you to spend no more than $24 for decorations for a party. Streamers cost $2 a roll, and tables cost $6 each. Use intercepts to graph the inequality that represent this situation. Find 3 possible combinations of streamers and table costs you can buy. So what I'm going to try to do, I'm going to take a picture of this and put it somewhere. So there we go. And I'm going to make graph paper because I like graph paper. So so what I'm going to do, first thing I want to do with the word problem is set up a variable. So I'm going to let something equal something. What do you think? Hello. What should I let S be? S, stop doing that, you stupid thing. S equals streamers. Okay. And what's my other thing? Streamers. And let T equal table costs. Table costs. And now, with this kind of graph, you just need to make it everything positive. So you just want to do a graph that is in the XY plane. So I'm going to try doing this. All you need to do is like here, going this way, and like here, because everything's going to be positive, because you can't buy negative table costs or negative streamers. And we're going to try to graph this, okay? So let's set up a couple equations. So your budget allows you to spend, or inequalities, no more than $24 for decorations for a party. And streamers cost $2 a roll, and table costs $6 a roll. How could I set up an inequality?
I have to graph it.
2, how much do streamers cost? 2S plus what?
Plus 6
6T. How much does that have to be?
is
Less than or equal to 24. You guys understand where that comes from?
Yep.
Okay? Now, it doesn't matter which axis you let, in this case it doesn't matter which axis you let S be S and which one you let be T. So let's call this S down here and this T over here. Okay? And this is a nice one for, you can graph S, T, and you can do this using the intercepts. When S is 0, what would T have to be?
8.
No. 6 times what gives you 24?
8.
4.
Oh,
8.
I doubled that.
You doubled it.
I'm not
Okay?
good with that.
When T is 0, what would S have to be? 12. Okay? So I have 2 points I can now graph. When S is 0, T is 4, and it so happens that my graph is set up nicely for that. S is 0, T is 4, so we're just using a 1-to-1 scale here. There's a 0.04. And when S is 12, T is 0. So I'm going to come over here. 1, 2, we can count by ones. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? And I'm going to graph that line in, it's a weird line.
Yeah, just a little bit.
What's weird about it?
Well, the fact that it's going down instead of up.
Well,
Well, I know it's, your money is decreasing.
Now-
It's weird.
where should I shade? Where should I shade? Above this line or below the line? Let's figure it out. Plug in this 0.00. Is 0 plus 0 less than or equal to 24?
Yes.
Yes. So I'm going to shade below this line. And you can't spend negative money, or you can't buy negative streamers or negative tablecloths. I don't have to worry about below those two lines. You see that?
That's cool. It's like a triangle.
It is like a very good. Thank you. But it is like a triangle. So it says, find 3 possible combinations of streamers and tablecloths you can buy. So in other words, find any points in this region. Could I buy 12 tablecloths and or 12 streamers and no tablecloths? Could I do this? Could I pick this point? Does this point work right there?
No.
Yes, this point right here
Yes.
works. That's what I'm pointing to. So one possible combination is 12 S's, 12 tablecloths, 12, what's this, streamers, right? Streamers and 0 tablecloths. Who can give me another possibility? What's this point right here? 2, 1, right? I could use two tablecloths. Whoops, there should be a comma there. 2 streamers and 1 tablecloth. Who can give me one more?
3 streamers, 1 tablecloth.
3 or you could do 3 and 1, right? You could do 3 and 1.
Or
What
you
else?
could do 3 and 2.
You could do 3 and 2, right? What if I want to buy like the most stuff I could?
6 and 2.
Maybe 6 and 2? Where would 6 and
6
2?
streamers and 2 tablecloths.
1, 2, 3, 4, 5, 6, 2. Ah, very good point. That would be like the most stream. Where would be another like good point I might want to, like over here?
2, 4.
Yeah, like what's this? 1, 2, 3, 1, 2, 3. Right? I could do 3, 3. Well, and that would exactly use up all my money. So this is like a real life problem. It's like, I have so much money. How many
Things can I get?
How many things can I buy? Maybe you want to, I have so much money, maybe you want to, what do you want to buy?
How many cars can I buy with $1 million?
Yeah, how many cards, or how many,
That would be a very bad one.
yes,
because I'm on
maybe you want to go to the store and you want to, what would be a good thing that you want to buy? Like iTunes. Maybe you want to buy so many songs and you want to download so many games.
Well, the problem with that is they add tax, and then you can
Not
still-
on iTunes, they don't.
Yeah, they do. It's
They do.
tax free.
Oh, let's stop, we're done, okay?